Welcome back to Number Math. This is for my Math 2 crew. This is your Unit 5A review. Now, unit reviews for the majority will be in all black and white. There will be some color applied, but the goal is to get you completely faded off from the initial learning. Okay, so here is a solid reteaching moment for you. Question 1. What is the midpoint between 15.3 and -7.8? Okay, here's our midpoint formula, x1 plus x2 divided by 2. All right, y1 plus y2 divided by 2. It's truly as simple as that. Okay, I look at my first set of coordinates. We just go x1, y1. Second set, x2, y2. All right, from here, when it tells you plus, well, that means nothing's going to change from our x2 and our y2. So if our x2 is -7, I just want you to subtract 7 from your x1. All right, now our 8 is positive, so we will just add 8 to our y1. 15 minus 7, wonderful job. 3 plus 8, excellent. Divide each by 2. 8 divided by 2 is? Great job. 11 divided by 2 is? Exactly 5.5. Wonderful. Go ahead and circle your answer. That's all there is to that. All right, moving forward to number 2. All right, one endpoint of a segment is 4, -8. Now, the endpoint specifically, all right, I always want you to label as x1, y1. And the midpoint of the segment is 7, -3. The midpoint, always x2, y2. All right, because it's asking for what is the second endpoint of this segment. Now, I've pre-built in the formula for you just in case some of us may have forgotten it. Okay, so let's just find what our x2 is. Well, our x2 is, wonderful job, 7. 7 times 2 equals 14. We need to subtract our x1. So let's do minus. And our x1 is, wonderful job, 4. 14 minus 4 equals 10. All right, you have now found your first half of the problem. Now, you might want to check your answers. See how many have a 10 in the x spot, because it always goes x, y. All right, if there's only one with the number 10, go ahead and circle your answer. You don't even have to mess with y. But if there's 2 of them with 10 or 3 of them or all 4, well, you definitely want to solve for y. And it's just the same thing, except now we're just taking our y2 of, great job, -3. Okay, times 2 equals -6. Then we want to subtract our y1. So I'm going to put minus, and our y1 is -8. All right, equals 2. All right, now some of you in class did such a wonderful job that you said, but Mr. Richards, that minus -8, what else is that telling us? It does. When you have that minus negative, all right, I'm just going to circle it, that really turns into a plus. All right, so what I'm going to do is I'm just going to erase that. I thought that I had it on full, but I didn't, so let me just take a moment here. All right, we'll do plus equals 2. So your answer is 10 and 2. All right, for number 3, Km is 12.2 units long. If Km is dilated by a scale factor of K equals 0.6, scale factor is just a multiplier, all right? What is the length of K prime M prime? Okay, well, Km is 12.2. All right, and then if we just multiply our scale factor of 0.6, you get 7.32, and that is your K prime M prime. All right. Now, number 4, if a dilation with a scale factor of 7/8 takes place, what type of dilation is this? Okay, well, 7, let me actually get rid of that. I'm going to save a little space here. I also need to change this to whole. I prefer that. All right, so let's take a look. We have 7/8. Which equals, well, if we were to eat a pizza and it was pie cut into 8 slices, and there were 7 slices left, do we have a whole pizza? No, we don't. So let's do this. Let's pull in our calculator. Let's do 7 divided by 8. It equals 0.875. All right, so we don't have a whole pizza. We have 0.875, which equals a reduction, okay? Because when you multiply any number to a number that is less than 1, it's going to shrink, all right? It's going to be reduced. It's going to get smaller. And here's a number that's less than 1, 0.6. And we took 12.2 and we multiplied it to 0.6. It equals 7.32. It got smaller. It was a reduction. All right, so we're going to put, just for a note, 7/8 is less than 1, and that's why we get the reduction. Now, Mr. Richards, what if there were 8 slices? Because no one ate a piece yet. Well, 8 over 8, or any number divided by itself, is equal to 1. All right, so that's going to equal a congruency transformation. So basically, it's just taking a shape, and since we've been working with a lot of triangles, it's just taking that shape and moving it to a different spot along the grid, okay, or along our graph. Or it might be rotated. It might be reflected, but it's the same size, same shape. All right, so with 1 equaling 1, or because 8/8 is equal to 1. All right, that's why we have a congruency transformation. All right, what do we know about congruent? Same size, same shape. Wonderful. All right, but what if there were 9/8? Well, 9/8, whoa, do we have more than one pizza? We do. And how much do we have? Well, let's do 9 divided by 8. We have 1.125. All right, that number is now exactly greater than 1. All right, so this equals an enlargement, because anytime you take any number and multiply it by a number that's greater than 1, it's going to increase. All right, so we're just going to put 9 over 8 is greater than 1. So if you see any of those three, it should be a simple solve. All of these really are, guys, all right? Let's just continue to put forth great effort. You all have this. Let's go. Number 5. What is the scale factor of the dilation pictured below? Okay, divide coordinates. That's all we're doing here, okay? We're going to take our image, because our scale factor equals our image over our pre-image. We're just setting up a fraction, and fractions tell us to divide. All right, our image is your dashed line or your primes. Pick any of these, A, B, or C. All right, you guys want to pick A prime? Wonderful. Let's just take a look at our x-coordinate. You only have to do this one time. All right, now if it's our image, which is our dashed figure here, all right, and our A prime x-coordinate is 1, I'm just going to do this for us, okay? I'm going to put A prime equals 1. We will then set that over our x-coordinate of A. Well, our x-coordinate of A is 3. Why isn't it the 6? Because coordinates always go x, y. All right, so we do that. 1 over 3 equals 0.33. All right, go ahead and circle your answer. Now in class, I asked you to try the one below, all right, because I did it as coordinates again. Now for the video, I decided to add in sides. This time we will work with sides, all right? We just have to find the corresponding sides. Oh, okay, you want to choose A prime to B prime, all right? So we'll go side A prime to B prime. You know what? Let's do this. A prime, B prime equals 15. All right, we set that 15 over AB. Well, A to B is 30. And 15 over 30 equals, yes, 0.5. Now back to what we were discussing earlier, okay? If you know that your image has gotten smaller from our pre-image, well, that means your scale factor has to be less than 1. So sometimes people make the error and they actually write it as 30 over 15, but 30 divided by 15 is 2, which means our dashed image here, all right, would have been greater than our solid line pre-image. So you know it's wrong just by that. Moving forward, number 7, I built in our little code here, all right, T equals top, L equals left, R equals right. Left, center, right? No, it's top, left, right. I know. All right, great holiday game for the kids. All right, so let's just go ahead. It's asking us to identify the similar triangles. All right, well, let's take a look. Triangle BCA. All right, well, B is represented by a T because it's on top. So right above our B, I'm just going to put T. All right. Now, it says C, and our C goes to the right side. So I'm going to put an R over it, which makes our A our L. We have TRL. All right, triangle EDF. Well, E starts on top, perfect. D breaks to the left, and F is to the right. TRL, TLR. Oh, they're different. They do not align. Get rid of it. Let's try the next one. CBA. C is to the right, B is on top, and A is to the left. F is to the right, D is to the left, and E is on top. Our RTL and RLT the same? No, get rid of it. All right. Now let's go ahead and try BCA again. Well, we already did BCA. It's TRL, so I'm just going to go ahead and put TRL. All right. Then it's saying EFD. E is on top, F is to the right, and D is to the left. We are officially live on TRL. It's similar to TRL, all right? Do you see how those align? I can make it a lot simpler. You can use the same strategy for the next one. All right, you're going to have to identify the similar triangles again. Now, we have a big triangle of ABC. All right, they might name it CAB or CBA. I don't know. All right, and then we have a smaller one of ADE or AED or DAE, however they decide to go. But as long as we use the top, left, right strategy, it's guaranteed every time. This time we'll write them below just because our E and our A and C are a little low to the earth. All right, so let's take a look. A, E, all right, right away, AE to B. Well, this doesn't connect a dot here, okay? That's not even representing a triangle that's given to us. Get rid of it. All right. Now triangle ABC, let's take a look. A to B to C. Okay, it does make the large triangle. A is to the left, B is on top, C is to the right. And then we have similar to triangle AED. AED. Oh, it does make the smaller one. A is to the left, E is to the right, and D is on top. So we have LTR, but then we have LRT. Unfortunately, we have to try our next answer choice. All right, we have ABC, which we already labeled as LTR. So let's just go ahead and put that right above. And then we have ADE. Well, A is to the left, D is on top, making E to the right. And LTR is definitely the same as LTR, making triangle ABC similar to triangle ADE. All right, let's move forward to the next one. All right, now this is where we get into statements, okay? Our statements are always going to be angle, angle, side, 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 angle, side, or can't determine. Okay, real quick, so when we read this, when we see this here, we have our large triangle of FDE, and then we have is similar to triangle GDH. So we have a smaller triangle within the large one because of our side splitter of GH here, creating that for us, okay? Now, if this assists you, what I want you to do is just go ahead and draw them out. All right, we're going to pretend like this is the larger one, and we're going to name it exactly what they named it, FDE, but we're going to follow the pattern, FDE. Okay, so we have our F, we have our D, we have our E. Okay, now let's go ahead and make the smaller one. All right, again, visuals are great for some of us. They always have been for me. And I'm just going to go ahead with GDH. So GDH, label it the exact same way. Left top, right. Oh, great job, guys. Thank you. All right, now let's start putting pieces together. Do you see how that they both share that angle D? All right, when they share an angle like that, they're telling you that it's congruent because it's the exact same angle that they're sharing, okay? Nothing changes. So we do have a similar angle. Okay, let's continue to fill in the gaps. Now we have D to F. D to F is, whoa, it's 5 plus 10, giving us 15. So D to F is an entire 15. All right, I know in class we did DF equals 10 plus 5, which equals 15. So just a note in case you do forget that. That's all. And then from D to E, all right, we have exactly. Guys, great job. Way to learn. All right. Way to put it together. DE equals 8 plus 16, which equals 24. Wonderful job. All right. Then we have GD, all right, is a 5. And DH is an 8. Wonderful. All right, now let's go through our answer choices, okay? Angle, angle. Is there enough information for our answer to be angle, angle? Absolutely not. Great job. Reason being, they're only giving us one angle, all right? That's it. You have to have the arch in there to show that congruency, or it would give the degrees. So we got rid of angle, angle because there's only one angle congruent. All right, now let's take a look. Our next answer choice is side, side, side. Process of elimination. Guys, the best part about standardized tests is that you can use the process of elimination. Usually within any standardized test, you can narrow it down, whether you know the content or not, to a 50-50 shot every time because the answer is always within the problem. All right. Side, side, side. Let's take a look. Well, 15, 24, it's not giving us all three sides. 5, 8, definitely not all three sides. All right. We can get rid of side, side, side. And we can put only providing two sides. All right, so if that assists you, use it. Well, let's take a look. Can we do side, angle, side? Oh, well, we definitely have one angle, and they both have two sides. Now, do we remember the strategy or the key to this? Yes, exactly. And I'm going to note this, okay? I'm just going to put C. I'm going to put in a little arrow and a star it. So we know side, angle, side. Our angle needs to be smushed between two sides, meaning our angle of D, if we go this way, that has to be a side length. And if we go this way, there has to be a side length, which there is. Is it the same the other way? Yes, there's our angle of D. Bring it down. Oh, there's a 5. It's giving us the side length, and this is giving us the side length. So that angle of D is smushed between the two sides of 5 and 8, and this angle D is smushed between the two sides of 15, 24. Circle your answer of side, angle, side. Angle must be smushed between two sides in order for that to work. All right. Number 10. I just want you guys to take a look at the answers above. All right. Which statement would justify triangle GHI is similar to triangle JKL? Well, here's GHI and here's JKL. Let's go through our answer choices. Angle, angle. Well, okay. We have an angle with an arch, an angle with two arches, an angle with an arch, an angle with two arches. All right. As you can tell, this is already giving us enough information just by angle, angle. They both have two angles that are two pairs of angles that are congruent to one another. G is congruent to J, I is congruent to L. All right, so for right here, you would just put angle, angle, or circle that answer choice. All right, now how about triangle ABC to triangle DEF? Well, ABC, DEF. All right, can we use angle, angle No, it's not giving us any angles, no arches. All right, no curves on the inside. All right, now if there's none, can we use side angle side? No, we cannot. What we can do is we can check for, let's see, 1, 2, 3, 1, 2, 3. We can check for side, side, side. Okay, so what we're going to do is we're going to make a large fry. We have our medium fry. We have our small fry. Now, I used to play small fry basketball back in the day, but hey, now we're just ordering value meals. Okay, so what I like to do is, because I like to work with numbers greater than 1, I start with the largest number and the larger of the two triangles. Largest number, largest triangle is 24. You put that over the largest number from your smaller triangle, which is 8. 24 divided by 8 equals 3. Number greater than 1. All right, now we take the medium-sized number, which is 15. Wonderful job. And then we will set that over the median from the smaller, which is, great job, 5. 15 divided by 5 equals 3. Okay, let's check the last one. Let's take our smallest number from our larger triangle of 9. And we will set that over our smallest number from our smaller triangle of 3. And 9 divided by 3 equals 3. All three sides are proportional. All right, that means we can use side, side, side. So even if you didn't know anything, but you had heard the term angle before, and you heard the term side, well, instantly I would think that that 9 represents a side because it's nowhere near an angle. All right, and I would think the same for all of those. So I would easily, without even knowing anything in math, eliminate angle, angle. And then I would definitely eliminate side, angle, side because, again, there's no angles. But there is 3 side lengths for each. So if you knew nothing at all, and you didn't even know about proportionality, you've just narrowed it down to a 50% shot. All right, the answer is always within the problem. It's the best part about a standardized test. Now, which statement would justify triangle DEF is similar to triangle GEH? All right, so we have DEF and we have GEH. All right, so they share something in common. Again, what do they share? They share that E. That means they share that angle. All right, they give off vertical angles, which are congruent angles. All right, now, if we take our angle of E and we go from E to F, is it giving us anything? No, it's not. All right, so right away, we know it doesn't have 2 congruent angles. Get rid of it. All right, it's not giving us all 3 sides of both triangles, so we can definitely get rid of that. So we're testing for side angle side. All right, now, here's our side. I always like to look at the angle. All right, the angle is E. Now, for the smaller triangle, if we go from E to D, it has a 5. It's giving us a side length. Perfect. But from E to F, it's not giving us that. All right, so that's right there. No good. So right away, you can circle, can't be determined. You don't even have to check the other, but take a look. We have our angle of E. From E to G, great. Has our side length, but E to H doesn't. So that means our angle is not smushed in between 2 side lengths that are provided for us because the 24 is over here and the 6 is over here. So circle can't be determined. Number 12, which proportion can be used to solve for x? Okay, let's just take a look at what they're giving us. They're giving us 15 over 6. Okay, like that works. Equals 28 over 11.2. Well, I don't see x involved anywhere. So if I'm looking at these and I know I have to solve for x, well, it doesn't have an x in it. All right, again, if I knew nothing about math and I came in blind, instantly, I would get rid of this because x is not even involved. Not solving for x. That's why we got rid of answer choice A. You're not solving for x. Now let's take a look at answer choice B. We have x over 15. all right, equals 14.4 over 6. Now, when we set up proportions, all right, well, we do it from a side that is, corresponds with the side from the other triangle, okay? That's how you prove your proportionality. So if it's going x over 15, well, we wouldn't write it that way. So we would get rid of b, and we can just write the reason you got rid of it is because proportions are set up from both triangles, not just the one. All right, so we can get rid of that one. Let's try answer choice C. We have 28 over x. Oh, 28 over x. Well, what do we know about answer choice B? It's the exact same kind of thing. All right, go ahead and get rid of it. Now, answer choice D is saying x over 14.4. Now, do we see our x? It's in the exact same location as our 14.4. All right, that means it's corresponding sides, so that's perfect. This right here checks off. Equals 15 over 6. 15 over 6. Our 15 is all the way to the left, that side, and our 6 is all the way to the left, that side. That means they're corresponding sides. That checks off, and answer choice D is your answer. Number 13. It just says to solve for x. You guys have been doing a great job in class with this. All right, I'm not going to write statements. I'm just going to take visually what I know is corresponding sides. So I know if my x is to the left of this triangle, well, I need to take the side length to the left of this triangle, which is 12. Equals our last bit of information, which is 9, because we started with this triangle with the x, all right, which we could label triangle 1. This one you could label triangle 2. All right, so we'll put our 9 over our other piece of information, which is 27. All right, from here we just simply cross multiply. 27 times x is 27x equals 12 times 9. Well, what's 12 times 9? Let's figure it out. 12 times 9 equals 12 times 9, 108. All right, divide each side by, yes, 27. Great job. X equals 4. Circle your answer. Moving on to number 14. What is the length of side HI? Oh, just another one again. Well, HI is to the right, and it's an X. I'll set that over to the right side of this triangle, which is 9, equals our other piece of information, which is 12, over our other piece of information, which is 7.2. I know, you guys are bored with this. I get it. I am too. But it's great because you're all demonstrating such wonderful understanding. And we just did 9 times 12 above. Weird. 108. Divide each side by 7.2. Let me pull this back in. I'm just going to hit divide. 7.2 equals 15. X equals 15. All right. Solve for side AC. Oh, Pythagorean theorem. Okay. So if you're uncertain with this, if we're solving for our C value, sorry about the error here. This should have been a square to make that right angle for us. There we go. All right, not perfect, but not bad. All right. So if you were solving for C, you would just do a squared plus b squared. Put in your calculator just like that. All right. If you're solving for your b value, you take your c squared minus your a squared. And if you're solving for your a, that would equal c squared minus your b squared. Now here's the kicker. Remember, just like we learned in class, finding that hypotenuse, that c value, is always it. All right, that one you have to find. The other two legs we just label as a and b. always start at your right angle, at your square. All right, directly across from that will always be your C or your hypotenuse, okay? Then you can just label this A and this B. You could have labeled this B and this A. It does not make a difference. C has to be appropriate every time. So in this case, we'll solve for B. So I'm just going to do B equals, and I'm going to follow the exact formula it's giving me. My C value, which is 23, make sure to put the parentheses because your calculator needs that, okay? Minus our A labeled value of 14. We'll square that, hit enter in your calculator. So I'm just going to go ahead and enter it. Hit second, hit x squared. So I hit second, this blue button. I went down to x squared, tapped on that. All right, got us our radical here. We're going to open a parenthesis. I'm going to do 23. I'm going to close parenthesis. I'm going to hit x squared again. All right, from here, we just follow the formula. Hit subtract. All right, we will subtract our A value. Make sure to open that parenthesis before putting in your 14. Close that parenthesis, hit x squared one more time, followed by enter. And what do we have? 18.24. We can round that up to 18.25. All right. So B equals 18.25. Now, if you had a number that's greater than 23, well, your hypotenuse or your C is always the largest. So you would know it's a wrong answer. All right, just to let you know. Find the altitude for BD. All right, I like this one because we don't know what BD is. All right, but we do know that BD, this line right here, I'm just going to put it in blue. Highlight it, just a little color for us here. All right, I'm going to label it with an X. Now, our BD, let me go ahead. That right there is our altitude. And it wants you to solve for the altitude. All right, I'm going to steal a Miss O hack right here that I love. All right, now altitude, we can represent with an A. We have to do A squared equals side times side, okay? So your A value is an X. So take your X, square it. Write it equal to side times side, 7 times 10. So your, I'll continue that in blue, X squared equals 70. Now, if we remember, all right, in order to get rid of that square, we have to take the root of that x squared, which means what we do to one side of the equation, we have to do to the other. Now we can pull our x out. We can set that equal to, again, hit second, hit x squared, type in 70, hit enter. 8.36 will make it 8.37 or 8.4 actually. Go ahead and circle your answer. All right, we found the altitude. All right, solve for side DB. Now, technically, you could just do 12 divided by 4 is 3. 3 times 12 is 36. That's the side length. Like, it truly is just that simple. But we're going to take Miss O's route again. All right, anytime we have these, we're using the altitude in the sides. Well, let's just try it again. Let's just do A squared equals S times S, all right? Now, what's our altitude this time? Well, our altitude is still this line here, all right? And we're just going to put it down to the side here. We know that's our altitude, which is 12. All right, so we're just going to take 12. We'll end up squaring that. And then we'll set that equal to our side times side, which is 4 times 3x plus 6. I threw it in parentheses because we have to distribute that 4 to both terms. All right, now 12 squared is just 12 times 12, which equals, great job, 144. So we take that 144, set it equal to 4 times 3x is 12x, 4 times 6 is, great job, 24. When we have a constant or a number by itself, we have to get the term with the variable by itself. on this side, which is 12x. So what's hanging out with 12x? Exactly, plus 24. How do we get rid of the old Ken Griffey Jr.? Subtract it from both sides because we do the inverse operation or the opposite. Okay, so we will get 120 equals 12x. Cancel them out. Okay, divide each side by 12. I'm going to put our answer over here of x equals 10, but we're not done yet because we haven't solved for the side. 10 will be an answer choice. Trust me. They want to try to get you right there. They want you to think that you're finished, but you're solving for the side of dB. So plug in your x value. We're just going to rewrite it. Here's dB, all right? So 3, open up a parenthesis because 3x is equal to 3 times x. All right, plus 6 equals 36, which equals dB. Circle your answer. All right, now again, you could have simply taken your altitude, divided it by your short side of your smaller triangle. So 12 divided by 4 is 3. Take that 3, multiply it back to the altitude of 12, you get the same answer of 36. It's truly that simple. All right, number 18, solve for side BE. All right, side splitter. All right, what do we remember about that? We can write it as x over 8.5 because it splits the total side of BC into BE and EC. So you write it as x over 8.5 equals 21 over 7. Not 7 over 21 because the x is on top in this smaller triangle built within. All right, so start with the 21. Put that over this 7. Yes, it is. We do cross multiply. 7x. 21 times 8.5 equals 178.5. Divide each side by 7. X equals, divided by 7, 25.5. And that right there is your side length of BE. All right. Moving forward, number 19, solve for x. All right. Now again, this is the one where we're solving for the parallel line itself. If you find it beneficial to draw out both triangles, feel free. All right. Do your large one. Doesn't need to be perfect, okay? Just needs to be close. Not even. As long as you can see it. Our larger triangles A, B, C. All right. Now from A to C, it's clear that it's a 60. From A to B, yes, you're correct. AB, all right, equals 28 plus 20, which is 48. Good job. So we're going to label this. We'll give it a 48. Then let's draw our smaller triangle. Good news is about notability can just make straight lines for you. And our smaller triangle within, ooh, didn't connect my dot auto though, is DBE. So DBE. All right, and D to B is 20, and D to E is x. All right, so if we're solving for x, I usually start with x, and then you just put it over its corresponding side, which is 60, because bottom line, x over 60 is your bottom line, equals our other two pieces, 20 over 48. What's the same thing on repeat? We cross multiply. 48 times x gives us 48x equals 60 times 20 gives us 1200. All right. Let's divide each side by 48. 1200 divided by 48 is 25. X equals 25. Go ahead and circle your answer. All right, moving forward, we have the length of a light pole's shadow is 210 feet. So the shadow is 210 feet. All right, here's our imaginary light pole. There's our shadow. All right, now at the same time of day, a 3-foot shrub Oh, okay, so like just a little shrub here. That casts a 9-foot shadow. Oh, so the shadow's bigger. Okay. What is the height of the light pole? Well, here's our light pole. And I'm just going to turn that light pole into a flagpole like I'm playing Mario Brothers. All right, now let's just go plug in the information. Our shadow is 210 feet. So I'm just going to put a 210 right here, representing our shadow. I'll put an X over here to represent the height because we don't know what that is. Now our little shrub or our bush right here is 3 feet tall, and it casts a 9-foot shadow. We have exactly what we need now just to set up the proportions and solve. So if I start with my X, well, and that line runs vertical, all right, our height, well, what's the height of the shrub? Put it over the height of the shrub. Equals our other two pieces, 210 over 9. 9 times X equals 9X. 210 times 3 equals 630. Divide each side by 9, and X equals 70. That right there is the height of your light pole. That completes the review. I mean, guys, truly, it's that simple, all right? A little bit of focus, a little bit of effort over this next day and a half, and this should be a 20 for 20. This should be a perfect hundo. Pause and go back if you need to. Rewind and go back if you need to. If you're uncomfortable with something, ask a question in class. All right, this is a great reteaching moment, but we're not live to give you that direct answer. All right, let's crush this thing. Let's go.